Alright, so this is the next theorem that we got to learn in this triangle unit. This is mid-segment of a triangle. So just to recap for you, this week we started out by classifying triangles. So y'all should know how to classify triangles by their angles and their sides now. Next day we did triangle inequalities, just figuring out if a triangle is a triangle based on the sides that they give you, and figuring out range and all that good stuff. Then that Wednesday and Thursday, that's when we did the angles of triangles. That's when we did the triangle angle sum theorem, exterior angle theorem, and we did isosceles and equilateral theorem on Thursday. So we covered a lot this week. And now we're doing the mid segment of a triangle theorem. This one went pretty well earlier today, so it should go well with y'all too. Anybody who hasn't been here, I suggest you watch some videos to catch yourself up. So a mid segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every triangle has 3 mid segments. I'll show you out here to the left what they're talking about. So, to the left out here on this triangle, I have a triangle ABC, which is my big triangle. Inside of that, I have 3 mid segments, DE, EF, and FD, that are connected and create a smaller triangle inside DEF. But we consider these mid segments. Reason being, on this side AB, point D is the midpoint of that side AB. That being the midpoint, I know that the smaller segment AD is congruent to the small segment BD. Same thing on the other side. E is in the middle of segment BC, or side BC. So I know since E is in the middle, BE and CE are congruent. Those two smaller segments. And then the last one on this bottom side, AC, F is in the middle of it. So that tells me that AF and CF are congruent as well. And if you see, as I went around, I did different markers for each pair of sides to indicate that this and this are congruent to each other, but they're not congruent to these two. These two have their own congruency to each other. And the same thing here. These two are congruent to each other, but they're not congruent to the other ones. You need to differentiate your sides with more markings. Alright. First part, name the 3 mid segments. Kind of just told them to you, but we're going to name them. First one is DE. Second mid segment would be EF. The third one would be FD. Moving over. Which segments are congruent by definition of a midpoint? And we're starting to use these terms for you. It's going to mean more to you next week, definition of a midpoint. So the definition of midpoint is me saying that D is the midpoint of AB. And by that definition of midpoint, I would know, since D is the midpoint of AB, I would know that AD is congruent to BD by definition of midpoint. Because if D is the midpoint, by that definition, then AD has to be congruent to BD. That's my first congruency statement I'm going to make. I'm going to say AD, that segment is congruent to BD by definition of D being the midpoint of that segment. Next one, I know that BE is congruent to CE by definition of midpoint. And then the last one, I know that AF is congruent to CF. Sliding on through. mid-segment of a triangle theorem. So here's the theorem. The theorem says the segment connecting the two, or the midpoints of two sides of a triangle, is parallel to the third side and has a length that is half of the third side. That is the mid-segment theorem. So before I start explaining the stuff down here to the right, let's go to the left and look at the figure and talk about it. So on this figure, they drew it out a certain way, indicating stuff for me. I got the big triangle here, ACE. Inside that triangle, they put a mid-segment, BD. The reason I know this is a mid-segment because they indicated on this side that AB was congruent to CB on this side, so I know B is at the midpoint on this side. And then on this side, they indicated that CD was congruent to ED, so I know D is the midpoint on this side. So if this segment is at the midpoint on both sides of my triangle, it's got to be a mid-segment. That's just the common sense of it. If the segment is at the midpoint on each side of your triangle, then this is a mid-segment. Alright, so since BD is a mid-segment, it has properties that I can understand with the side that it's parallel to. And up here they said the mid-segment of the triangle is parallel to the third side. Basically that third side that isn't being used, which is AE. And they are parallel. BD right here is parallel to AE. Now, since they're parallel and this is a mid-segment, they're telling you too that the third, it has a length that is half of the third side, saying BD would be half of AE. And that's the case over here. It says BD is, and that's what we're going to write, parallel to AE, and then in that case BD is equal to half of AE. Or if you're going in reverse, looking at it from the other way, 2 times whatever BD is would equal what A is. I'm saying a lot, but hopefully you're picking up a little bit of what I'm saying. Let's find out now. Who can I mess with? I know who to. So on this one, I'm going to throw a number at you. Say I say BD, this mid-segment equals 5. BD equals 5. I'm making this up, but I can. Chris, what would AE equal? Good. If BD equals 5, based on what they told you, BD is half of the segment that it's parallel to, then AE would have to equal 10. I'm not convinced yet. Maurice, say I tell you AE equals 16. What will BD have to equal?
Oh, 8.
Yeah, 8, man.
Why is that right?
This is what I'm telling you, though. The mid segment is half of the segment that it's parallel to. I'm talking slow, so y'all should be processing. Alright. Let's do 1 and 2. This ain't no tricks to this. Earl. Down here it says solve for the missing lengths indicated. Earl, look at the way they set it up. It says solve for CD. I'm asking Earl. Earl, what's the value of CD? No. Look at it, Earl. Look at CD. CD is inside the triangle. It's the mid segment, man. I know this one's upside down, but I'm trying to show you. It's parallel here to parallel here. It's 8. Huh? Go ahead. Solve for AC. Reese is doing this one.
This 8.
Yes, this is 8. Y'all need to notice the difference when you at the halfway point and when you at the whole thing. Alright, that's easy, but once again, you already know. We'll probably never ask you that way. Go to the back and see how we'll ask you how to solve these problems. The concept doesn't change. It's just we're using expressions. The concept hasn't changed at all. Now, it took them a while last period, longer than it did last year. But somebody came up with something good for me on this. Let me read it for you first, and let me talk around it, and let me make you understand. Solve for x and ln on here. This is a mid-segment problem. But they want us to solve for the value of x, and then they want us to solve for the length of ln. So once we find x, we got to plug back in and tell what ln is. First, we got to figure out how to solve for x. Obviously, in this situation, we're going to need to write some kind of equation. But I want to know what kind of equation you got to write. But let me talk about this first. I'm coming to you first, Jamal. Well, give me a sec. On this one, same situation hasn't changed. Only thing now, we have expressions on these problems. All we have now is that EF is my mid-segment, LN is the side that's parallel to it. Nothing has changed. It's just that now you need to figure out what the correct equation to write. And it ain't as straightforward as you might think it is. It's not hard, but it ain't. Some of y'all be thinking too easy. One thing I will say though, and somebody told me last class, and I don't think you're gonna go there, so I want to mention it. And I talked to y'all about this before. Somebody last class tried to say, oh, this plus this equals 180.
No.
Why would that be wrong? Why shouldn't we be using 180 right here? Thank you, Nasir. We are not doing angles at all. I haven't mentioned angles since we started. Don't use no 180, no 90 degrees, 60, none of that. These aren't angles. These are side lengths we're looking at. All the stuff we're talking about today are all side lengths. We ain't talking about angles at all today. You need to understand that these are not side lengths. I mean angles. So you're not thinking about 180, 180 degrees, none of that. Get that out your mind for right now. These are sides. All right, I said all I need to say. Jamal, what you got, man? What equation you think you're gonna write? Nah. To say that, Jamal, to say x plus 2, and other people are thinking that too. I'm gonna tell you why that would be wrong. To say x plus 2 equals x plus 10, you're telling me that segment EF is congruent to segment LN. Are they congruent? They're not. There you go. Now your mind working. I wouldn't write it that way. I would write it in front. Let me tell you what he just said. He said x plus 2 times 2 equals x plus 10. Yeah, that's what you need. You need to understand, yes, the mid-segment still needs to be doubled. You can't write it the way it is right now because these two things aren't equal. So you can't just set these equal to each other because they're not equal. And you can see that. EF is not the same length as LN. But I can make it that way by times in my mid-segment by 2. So I can say 2 parentheses my mid-segment x plus 2. Whatever it is. I don't care if they put a number there, just a variable or an expression like this. Sometimes they may just put a number there. Whatever's there in the mid-segment, you need to times that by 2. And that equals whatever your line that is parallel to, or the side that's parallel to it is. X plus 10. This is what you need to solve. And before we, you can solve this, but yeah. Yeah, I hope y'all remember how to distribute. I'm gonna let y'all solve that. I don't want to solve it. Hold on, I get 3 different numbers just now. Somebody said 16, somebody said 5 and 6. Yeah, 6. I got you. Hold on. So let's just figure out x first. Y'all solve for x. Make sure all y'all get 6. I don't want to do work for you because I feel like I'm cheating you by just doing the equations for you. You better have the work on your paper. Don't just write x equals 6 on your paper. These are your notes. Take pride in your notes. Solve your stuff out so you can go back and look at it. If you need help, talk to somebody next to you. Ain't no shame. Honestly, at this point, I think I got rid of everybody that don't know how to solve equations anyway. Everybody should know how to solve equations. So x equals 6, yeah. And then most of y'all sound like y'all plug back in already. You know, you plugging back into this one, so yeah, ln equals 16. Only thing I will say, because some kids will try to think about it this way. The same way we multiplied the mid-segment by 2, I used to have kids last year to say, well, instead of doing that, I can divide my bigger segment by 2. The only reason you don't want to do that, you run into danger sometimes dividing this by 2. Because you'll run into it on this one. Because you got x right here. How you going to divide x by 2? What you going to get when you divide x by 2? You're going to get 1/2 x, right? A fraction. Y'all know y'all bad at fractions. Why would you want to start using a fraction? And what if this was an odd number? What if this was 9? You divide that by 2, you're going to get 4.5, a decimal. No. When you multiply the mid-segment by 2, you'll never get fractions or decimals. Always do that part by 2. Don't divide this by 2. And let me show you. I like to have kids to try to do it. I showed it last year. I don't even like showing it to y'all that much no more. But if you try to do the big part divided by 2, you're going to end up getting something like this. You're going to end up getting x plus 2 equals 1/2 x plus 5. It's going to get real crazy. You don't want to use that. This is easier. Multiplying the mid segment, whatever that is, by 2. Doing that and just solving. Alright. Number 4. Looking at it. This looks like a Dior problem. Number 4. Solve for x and then VW. So we need to solve for x on this one. Dior, I just need to know the equation we need to solve for x. I said your name at least 3 times just now. Nasir, let Nasir do this. Okay, so can you just read that out to me? 2 times. Okay. From what? So you're saying equals x plus 21. So what you gonna do with that negative 2x plus minus 6? Thank you, Jamal. Jamal said you don't have to use that. I agree. That ain't gonna help us find x on here. I mean, after we find x, we can plug back in and get what mn is since they put an expression on it. But that's not gonna help us find the value of x on this. I told you sometimes there are distractors in the problem. You don't have to use everything you see. You need to just be confident and understand that concept enough to know that you don't have to use that. If you're looking at the way this is set up, this is your mid segment right here. This is the side that's parallel to it right there. Those are the only 2 things you need to write that equation. Solve for x. The mid segment and the side that's parallel to it. You just need to understand the mid segment is half of that, so you need to multiply by 2. And then you need to solve for x. And don't freak out about it. X is negative on this one. There, what you got? Huh? What you got for x? -9. So x, you should have got -9. Alright. Then after that, it's fine. The kids freaking out when they got negative. Your x value can be negative. It's just your distances. Your lengths can't be negative. Like VW, when you get that, it shouldn't be negative, or whatever else you get on here. You shouldn't have any negative lengths around your triangle. But you won't. Because when you plug back in for VW, -9 plus 15, like I said, that's what? 6. So VW was 6. And if you wanted to even, before you even check, you should know that, what's that, LN? What's LN have to be if VW is 6? It has to be 12, right? It's double of that. But you can check it anyway. -9 plus 21, that's going to give you positive 12. So it's good. What's up? Equals what? I'm saying you said it equal to what though? You said it equal to what? What was your equation? You should have came out the same way. I mean, if you did, I mean, that means that this triangle is isosceles, and that MN and LN are congruent. That could possibly be the case, but you don't need that. I wouldn't try that in the. It only worked out in this case because this might be an isosceles triangle. Yeah. Because if you plug into this, you should get if that's the case, if I plug -9 into this, I should get 12 over here. So -2 times -9, that's positive 18. Yeah, you'll get 12. So this triangle is isosceles then. That's why. Yeah, but don't do that on any other one because it may not be isosceles. And it may not work out that way. Alright. Now here, last part. Make sure you pay attention because you're going to need this for the stuff you do later. In a triangle, if 3 mid-segments are joined, the perimeter of the triangle, or perimeter of the smaller, forgot a word, triangle is half the larger triangle. Yeah. I'm going to explain this to you, help you understand it. So over here, you got triangle ABC. That's my big triangle, ABC. Inside of that, I got 3 mid-segments, DE, EF, and FD. I got all 3 of my mid-segments in. They formed a smaller triangle inside of this big one. What they're telling you is, if you have all 3 of your mid-segments, and they're joined together, the perimeter of the smaller triangle, formed by the mid-segment, is going to be half the perimeter of the bigger triangle. And that's true. Because if you think, each mid-segment is half of the side it's parallel to. So if I got all 3 of my mid-segments in, all 3 of those segments should be half of whatever this bigger perimeter is. Y'all follow what I'm saying? Because y'all should know what the word perimeter means now. Alright. If that's the case, if I tell you the perimeter of triangle ABC is 84. Who I want to pose this one to? Aiden. If I tell you that, what's the perimeter of triangle DEF? Thank you, sir. If I tell you the perimeter of triangle ABC, the bigger one is 84. The perimeter of the smaller triangle DEF would have to be 42. Y'all follow that? It's half, yes. And you're going to see that down here. Let's apply it. Using the diagram above to answer the following questions. Number 5, it says, given AB is 26, BC is 20, DE is 7. Points D, E, and F are midpoints. Determine the perimeter of triangle DEF. So on this one, you got to draw this out so you can see it. And I want you to draw it out too. Make a decent sized triangle on here for this one because you don't need to show much work in this section. Make a decent sized triangle. I'm gonna label that triangle A, B, C, and then inside of that I'm gonna put my midpoints in. I'm gonna make it pretty much like this triangle up here in this figure. Put midpoints in. Between A and B, I have the midpoint of D. Just kind of guess what my middle is. Between B and C, I have the midpoint of E. And between C and A, I have the midpoint of F. So this is D, E, F. Then I want to connect those. There you go. Alright, so I drew my situation out. Now I need to label it. They said AB was 20. So from A all the way to B, that's 20. 26, thank you. I'm sorry, I'm reading the wrong one. I'll make that a 6. Thank you, guys. That's 26. Sorry. B to C is 20. And then they say DE is 7. So DE is right here. This is 7. They want to know the parameter of triangle DEF. Let you stare at it for a second. Anybody got any ideas? Once you they want to know the parameter of triangle DEF. You're just a little bit off in your thinking. Okay. Listen. No. They want to know the parameter of triangle DEF. Y'all can't figure that out.
Oh, 14.
14 for what?
DEF, because like, don't you got the times? That's the middle.
Let me help y'all out. Let me put some more stuff in. Let me label a little bit more. So for me, I said all these were mid segments, right? Well, DEF, we need to know the parameter of that. So basically, we need to know all the mid segments. We got DE. That's easy. DF, side DF, or mid segment DF. That's parallel to what side? Nope. What side? BC. DF is parallel to BC. So let me ask you again. What's DF? 10. Okay, EF is parallel to what? Let's just talk about parallel right now. EF is parallel to what? Who? AB, right?
Oh, half of 20.
So y'all said 13, yeah? Now y'all following. So now I ask you, what is the perimeter of triangle DEF? Thank you.
I get what you did. Half of 20 is 10, half of 26 is 13. Oh, yeah,
So 30. Alright, let's hit number 6. Number 6, and I want you to draw this triangle a little closer to the left because we're going to need the right to solve too. We're going to do the same triangle again, label it, make it closer to this other triangle, get it closer to the left though, because we need space to solve out to the right. You want it to be a decent size one too again, because you need to label it. Alright. So A, B, C, D is in the middle on this side, E is in the middle over here, F is in the middle down here. Oh dang, I missed. After that, you want to label. It says given DE is 4x minus 7. So DE is 4x minus 7. EF is 2x plus 13. FD is 7x minus 8. They say the perimeter of triangle ABC is 152. Solve for x. Solve for the value of x. Somebody come up with something for me.
Might be wrong.
I'd rather you think than not think. I don't care if you get it wrong. At least you're trying.
4x minus 7 equals 7x minus 8. That's 2x. Oh! You gotta divide 2. 152.
Okay.
Divide by 3.
Maybe 4x minus 7 plus 7x minus 8 plus 2x plus 13. You just have to
There we go.
have it.
Alright. So it says the perimeter of triangle ABC is 152. That's nice. We don't need ABC though. We need DEF. So like Jamal said, you need to take 152. Understand that's the bigger one. You need to divide that by 2. First thing you need to do 152 divided by 2. Get the perimeter of your smaller one, which would be what, 76? So 76 is going to be the perimeter of DEF. And then from there, now you're ready to write an equation. And like he said, the equation is going to be 4x minus 7 plus 7x minus 8 plus 2x plus 13 equals 76, which is the full perimeter of triangle DEF. And then you solve for x. Let me know what you get. Oh, well, that happened quick. Yeah. After that, we good.